November 20th, 1943, Betio Island, Tarawa Atoll, Gilbert Islands. The pre-dawn darkness gives way to the thunder of naval bombardment as battleships Maryland and Colorado pound Japanese positions with 16-inch shells. In the lagoon, Marines of the 2nd Marine Division wade through chest-deep water, their landing craft grounded on the coral reef 500 wide from shore. Among them, Staff Sergeant William Bordelon of the 1st Battalion, 18th Marines, grips his equipment bag containing demolition charges, while his M1911A1 pistol rides secure in its holster, already soaked with seawater but mechanically perfect. The Japanese defenders, 4,500 strong under Rear Admiral Kei Shibazaki, have transformed this tiny coral island, less than 3 square miles, into a fortress. Their officers carry the Type 14 Nambu pistol, the Empire's standard sidearm chambered in ATX 22mm. As the Marines struggle through the killing field of the lagoon, Japanese machine guns open up from concealed pillboxes. The unexpected low tide has turned what should have been a quick amphibious assault into a desperate wade through waist-deep water under murderous fire. What unfolds over the next 76 hours will demonstrate with mathematical precision the superiority of American small arms design, particularly the M1911A, one firing its devastating 45 ACP cartridge over Japanese weapons that fail when needed most. In the close quarters, hell of Tarawa, where combat distances shrink to feet and inches, the difference between a 230-grain bullet delivering 370 FTLB of energy and a 100-grain projectile with barely 220 FTLB becomes the difference between life and death. The battles raging across the Pacific in 1943 reveal a fundamental truth that transcends mere technical specifications. The chasm between American and Japanese military sidearms reflects not just different design philosophies, but vastly different industrial capabilities, tactical doctrines, and understanding of what makes an effective combat weapon. The M1911A1 automatic pistol, firing the .45 automatic Colt pistol cartridge, represents the culmination of decades of American combat experience and industrial innovation. The Type 14 Nambu, with its underpowered 8mm round and fragile mechanism, embodies Japan's struggle to match Western military technology while lacking the industrial base and combat feedback necessary for effective weapons development. This disparity would manifest itself in every close-quarters engagement from Guadalcanal to Okinawa, where the thunder of the American .45 consistently overwhelmed the inadequate pop of the Japanese 8mm. The story of these two weapons is more than a tale of ballistics and manufacturing. It is the story of how industrial supremacy and engineering excellence determine victory in modern warfare. The genesis of the M1911A1 lies not in the Pacific, but in the Philippine jungles 4 decades earlier. During the Philippine-American War of 1899 to 1902, American troops faced a horrifying tactical problem that would reshape military sidearm development forever. The Mororo Juramados, Muslim warriors who bound their limbs with leather to prevent blood loss and ingested native drugs to dull pain, launched suicidal charges against American positions. The standard Army sidearm, the Colt Model 1892 double-action revolver chambered in .38 long Colt, proved catastrophically inadequate. Colonel Louis Lagarde documented the typical encounter in his medical reports. Soldiers would empty their revolvers into charging Moros, placing multiple shots center mass, only to watch in horror as their attackers continued forward to kill Americans with blade weapons. Lagarde's 1904 report described Antonio Caspi shot 4 times at close range, with 38 rounds, 3 bullets perforating his lungs, 1 passing completely through his body, who continued fighting until finally stopped by a rifle butt to the forehead. The .38 long Colt's 150-grain bullet at 770 ft/pers simply lacked the kinetic energy transfer necessary for immediate incapacitation. This failure prompted the most comprehensive ballistic study ever undertaken for military small arms. The Thompson-LaGarde Tests of 1904. Colonel John T. Thompson, who would later develop the Thompson submachine gun, and Major Louis Anatole LaGarde of the Medical Corps were tasked with determining the minimum effective caliber for military pistols. At the Nelson Morris Company Union stockyards in Chicago, they conducted tests that would be considered barbaric by modern standards, but provided crucial scientific data. The tests involved shooting live cattle and human cadavers with various calibers: 7.65x, 65x, 21mm, Parabellum, 30 Luger, 19mm, Parabellum, 38 Long Colt, 38 ACP-45, Colt 476, Ely, and 455 Webley. The methodology was precise, recording time to incapacitation for live animals, measuring body sway in suspended cadavers, examining wound channels through dissection, and the newly developed X-ray technology. The results were unequivocal. Animals shot with 30 Luger showed minimal distress even after 10 rounds. Those hit with 9mm or 38 calibers showed greater effect, but often required 8 or more shots. Animals struck with 45 caliber rounds typically collapsed by the 4th shot, with immediate and severe physiological trauma evident. The cadaver tests revealed even more dramatic differences. When bullets struck bone shafts, the researchers assigned numerical values to body oscillation. The 45 caliber rounds consistently produced 2 to 3 times more movement than smaller calibers. The board's conclusion was absolute. A bullet which will have the shock effect and stopping effect at short ranges necessary for a military pistol or revolver should have a caliber not less than 45 in. They noted that below this threshold, no amount of velocity increase within handgun parameters could compensate for insufficient bullet mass. John Moses Browning, already renowned for his firearms innovations, had been working with Colt on a 41 caliber semi-automatic pistol when the Army's requirements became clear. Browning rapidly scaled his design to accommodate a 45 caliber cartridge, creating what would become the model 1905. The cartridge underwent several iterations between Colt, Winchester Repeating Arms, Frankfurt Arsenal, and Union Metallic Cartridge Company. The original loading, a 200-grain bullet at 900 FT pers, evolved into the standardized military load, a 230-grain full metal jacket bullet at 830 FT pers from a 5-in barrel. The genius of Browning's design lay in its simplicity and robustness. The M1911 utilized a short recoil operation with a swinging link that lowered the barrel out of engagement with the slide during cycling. The single-action trigger provided a consistent, crisp pull. 2 safety mechanisms, a grip safety that must be depressed, and a manual thumb safety prevented accidental discharge while allowing rapid deployment. The 7-round detachable magazine could be quickly changed, and the pistol would fire the chambered round even without a magazine inserted, crucial when magazines were damaged or lost. The pistol underwent extensive testing from 1906 to 1911, competing against designs from Savage, Luger, and others. The torture tests were extraordinary, firing 6,000 rounds as rapidly as possible, accomplished in 27 minutes, dunking the heated pistol in water, mud, and sand between strings of fire. The Browning Colt design functioned flawlessly. On March 29, 1911, the U.S. Army formally adopted the automatic pistol caliber, a model of 1911 World War. A combat experience led to refinements incorporated in the M1911A standardized in 1924. The improvements addressed soldier feedback from the trenches, a shorter trigger to accommodate smaller hands, scalloped cuts in the frame behind the trigger for better reach, an arched mainspring housing for improved natural pointing, a longer grip safety spur to prevent hammer bite, wider sights for faster acquisition, and a shortened hammer spur to reduce snagging. These changes, while seemingly minor, reflected the American military's systematic approach to incorporating combat lessons into equipment development. The .045 ACP cartridge itself represented optimized ballistic performance within practical constraints. Operating at a relatively low 21,000 psi chamber pressure compared to 35,000 psi for 9mm Parabellum, the round prioritized reliability and barrel longevity. The 230 grain projectile's 451 in diameter created a wound channel significantly larger than its caliber due to tissue displacement. At 830 ft pers, the bullet traveled just below the speed of sound, avoiding the instability that occurs during transonic flight. The heavy bullet retained energy well, maintaining lethal force even at extended handgun ranges of 50 yards. When America entered World War II, the M1911A1 production transformed from peacetime trickle to wartime flood, demonstrating American industrial might at its apex. Colt's manufacturing company, holder of the original patents and production expertise, immediately expanded production at their Hartford, Connecticut facility. But even Colt's maximum capacity, approximately 800 pistols per day, by 1943, could not meet demand. The Ordnance Department, under Brigadier General Gladian Barnes, orchestrated one of the most successful distributed manufacturing programs of the war. Unlike the artisol approach required for complex weapons, the M1911A1's robust design allowed mass production techniques. Contracts went to companies with no previous firearms experience, but strong manufacturing capabilities. Remington Rand, the typewriter manufacturer, received their first contract in March 1942. Their Syracuse, New York plant, retooled from producing typing machines and adding devices, ultimately manufactured 877-651 M1911A1 pistols, more than any other contractor, including Colt. Their production methodology revolutionized pistol manufacturing, extensive use of stamping instead of forging, automated checkering of grip frames, and statistical quality control that maintained tolerances while speeding production. Ithaca Gun Company of New York, traditionally a shotgun manufacturer, produced 369,029 pistols. Their innovative use of investment casting for small parts reduced machining time by 60%. Union Switch and Signal Company of Swiss Vale, Pennsylvania, a railroad equipment manufacturer, produced 55,000 pistols of exceptional quality, incorporating improved heat treatment processes that extended barrel life by 30%. The Singer Manufacturing Company's contribution, though numerically small at 500 pistols, demonstrated American industrial flexibility. These sewing machine manufacturers produced educational guns of such quality that they remain the most sought-after M1911A variants among collectors. Singer developed tooling and processes later transferred to other manufacturers, multiplying their impact beyond their direct production. Part standardization was absolute. Any component from any manufacturer would function in any frame. Tolerances were deliberately loose, 0.03 to 0.05 in most critical dimensions, ensuring function despite manufacturing variations, field contamination, or thermal expansion. This interchangeability proved crucial when depot-level maintenance often involved assembling functional pistols from components of multiple damaged weapons. The ammunition supply chain matched weapon production. Frankfurt Arsenal, the Army's primary ammunition facility, produced over 1 billion rounds of .45 ACP during the war. Western Cartridge Company, Remington Arms, and Winchester Repeating Arms added another 2 billion rounds. Quality control was stringent. Every lot underwent accuracy testing, pressure testing, and function testing in multiple weapons. Specifications remained consistent throughout production. 230 grain bullet, 5.00 grains of powder, either bullseye or similar burning rate, producing 830 ft pers velocity, plus or minus 25 ft pers. Special ammunition variants demonstrated American innovation. The M12 shot cartridge, developed for aircrew survival kits, contained 118 pieces of number 7 and 1-2 birdshot in a paper capsule, effective against small game to 10 FT. The improved M15 shot cartridge used a blue wax capsule for better moisture resistance. Tracer rounds for training allowed shooters to see their bullet paths. Proof loads, marked with stanic-stained cases, tested +P pressure resistance during manufacturing. The Marine Corps table of organization evolution reflected combat lessons about pistol importance. In 1942, a Marine division was authorized 798 pistols, primarily for officers, NCOs, and crew-served weapon teams. By December 1943, after Tarawa, this increased to 1,377. By 1945, the authorization reached 1.77 pistols per division. The 1st Marine Division on Okinawa actually carried over 2,000 M1911A1s, with many riflemen acquiring pistols through unofficial channels. Distribution prioritized combat units. The 2nd Marine Division at Tarawa carried 56 M1911A1 pistols for approximately 18,000 Marines, 1 per 12 men. By Iwo Jima, the 5th Marine Division carried 1,189 pistols for similar strength, 1 per 10 men. Army units showed similar patterns. The 77th Infantry Division on Okinawa carried 1,134 M1911A1s among 16,000 soldiers. The Type 14 Nambu represented Imperial Japan's attempt to create a modern military sidearm, but its development history reveals the fundamental limitations that would doom it in combat. Colonel Kojiro Nambu, often called the John Browning of Japan, designed his first semi-automatic pistol in 1902. This Type A Grandpa Nambu superficially resembled the Luger, with its exposed barrel and distinctive knurled cocking knob, but operated on entirely different principles. The Type 14, adopted in Taisho 14, 1926 in the Western calendar, evolved from earlier Nambu designs, but incorporated supposed improvements based on Japanese military experience in China. The pistol utilized a locked breech mechanism with a floating locking block. Conceptually sound, but requiring precise manufacturing tolerances. The 8x 22mm Nambu cartridge, unique to Japanese weapons, fired a 102-grain bullet at approximately 1,065 ft/s from the Type 14's 4.6 in barrel. On paper, certain specifications seemed superior to the M1911A. The Type 14 held 8 rounds versus 7. Muzzle velocity exceeded the 45 ACP by 200 ft/s. The pistol weighed 2.03 lb unloaded, nearly half a pound less than the M1911A. Initial production models from Nagoya Arsenal and Kokura Arsenal showed excellent craftsmanship with deep bluing and careful hand-fitting of parts. However, these surface advantages masked fundamental flaws. The 8x 22mm Nambu cartridge, despite higher velocity, generated only 256 ft/lb of muzzle energy compared to the 45 ACP's 369 ft/lb, a 31% deficit. The lightweight 102-grain bullet shed velocity rapidly, retaining only 180 ft/lb at 50 yards versus 300 ft/lb for the 45 ACP. The bottlenecked case design, while theoretically aiding feeding, created extraction problems when chambers fouled. Japanese military procurement doctrine created additional complications. Unlike American forces who were issued weapons, Japanese officers were required to purchase their sidearms from their salary. A Type 14 cost 78 yen in 1940, approximately half a lieutenant's monthly pay. This economic barrier meant many officers received minimal training, viewing the pistol as a status symbol rather than a combat tool. Some officers, particularly those from wealthy families, purchased foreign pistols instead. Spanish ruby pistols in 32 ACP or inherited European revolvers were common. The Type 14's design philosophy reflected Japanese tactical doctrine that prioritized spiritual power over firepower. The Imperial Japanese Army's infantry manual devoted more pages to sword technique than pistol marksmanship. Pistols were considered weapons for executing prisoners, controlling subordinates, and ritual suicide, not primary combat tools. This doctrinal blindness prevented recognition of design flaws that would prove fatal in combat. Manufacturing quality deteriorated catastrophically as the war progressed. Pre-war Type 14s featured 17 distinct inspection stamps, careful polishing, and hand-fitted parts. By 1943, inspection marks reduced to 3, surface finishing was eliminated, and parts interchangeability degraded severely. Late war production from the Toriyamatsu factory showed tool marks, rough casting, and dimensional variations that would have failed pre-war inspection. The Type 14's most critical design failures centered on its controls and magazine system. The safety lever positioned on the left side, above the trigger guard, required the shooting hand to shift grip or the support hand to operate, impossible when wounded, carrying equipment or grappling with an enemy. The magazine release, a spring-loaded lever at the bottom front of the grip, often released inadvertently during handling, leaving the pistol unable to fire due to the magazine disconnect safety. The 1939 modification added a magazine retention spring, intended to prevent loss of magazines. This improvement made combat reloading nearly impossible. Magazines had to be yanked out against spring pressure, often requiring both hands. In tropical conditions, corrosion welded magazines in place. Marines reported capturing Type 14 with magazines frozen solid, hammered unsuccessfully in desperate attempts to reload. Production statistics reveal Japan's industrial limitations. From 1926 to 1945, approximately 400,000 Type 14 pistols were manufactured across all arsenals and subcontractors. Monthly production peaked at 3,500 units in 1944, but quality was abysmal. The Nambu Rifle Manufacturing Company, Chirokyo Company, and Tokyo Gas and electric subsidiaries produced pistols with such poor quality control that parts from different manufacturers or even different production runs from the same factory would not interchange. The Type 14 Nambu's failures in combat weren't isolated incidents, but systematic design flaws that reflected fundamental misunderstanding of combat requirements. Each deficiency, perhaps tolerable in isolation, combined to create a weapon that failed catastrophically under Pacific combat conditions. The safety mechanism represented the most immediate tactical liability, located above the trigger guard on the left side. The safety lever required either shifting the firing grip, losing sight picture and trigger finger position, or using the support hand. In close combat, where milliseconds mattered, this two-handed operation proved fatal. Marines reported numerous instances of Japanese officers futilely attempting to disengage safeties while being overrun. The M1911A1's ambidextrous safety, operable with the thumb of the firing hand while maintaining grip and trigger position, could be disengaged while drawing from the holster. The magazine disconnect safety, intended to prevent accidental discharge with the magazine removed, transformed into a critical vulnerability. When magazines were damaged, lost, or frozen in place by corrosion, the entire weapon became inoperable. Unlike the M1911A1, which would fire its chambered round without a magazine, the Type 14 required a functioning, properly seated magazine to operate. In the coral sand of Tarawa or volcanic ash of Iwo Jima, where magazines were easily damaged, this feature rendered countless Type 14s useless. The Type 14 lacked a slide-hold-open device. When the last round fired, only the magazine follower held the bolt open. Removing the magazine allowed the bolt to slam forward, giving no indication the weapon was empty. In combat, shooters discovered empty chambers only when triggers clicked uselessly. The M1911A1 slide lock, activated by the magazine follower, held the slide open after the last round, providing immediate visual and tactile indication of an empty weapon, while S